Hello everyone. Today we will study differential equations which are reducible to exact differential equations. In lecture number 1, we have seen what is differential equation, what is order and degree of differential equation, various applications of differential equations, along with formation of differential equation and how to find solution of differential equation when it is in the variable separable form. And this is lecture number 3 and part 1 of that. So I would like to request to all of you to subscribe channel on engineering mathematics to get latest updates and videos on it. So first we'll see what is exact differential equation. A differential equation mdx plus ndy is equal to 0 is said to be exact if there exists a function u such that mdx plus ndy is equal to du. So we can get solution by solving du is equal to 0, means u is equal to constant as a solution of such equation. But it is not possible every time to write given equation in this form, or it may take more time or it is time consuming, so it is not always convenient. So therefore there is a necessary and sufficient condition for differential equation mdx plus ndy is equal to 0 to be exact is dou by m by dou y equal to dou by n by dou x. Obviously here m and n are functions of x and y, and also u is function of x and y. So when necessary and sufficient condition is satisfied, there is a formula for solution. Means when differential equation mdx plus ndy is equal to 0 is exact, this condition is satisfied, then its solution is given by mdx, integration of mdx assuming y constant, plus integration of terms in n free from x dy, which is equal to c. There is alternate formula which can be obtained from this formula just by replacing m by n and x by y. So which is integration of n dy assuming x constant plus integration of terms in m free from y dx, which is equal to c. So equations reducible to exact differential. When, as we know, we can convert some of the equations to the exact differential. We can convert some of the equations which can be convertible to exact differential equations. It is not possible to convert every non-exact differential equation to exact differential equation. While converting, we use integrating factor, which is a multiplying factor, and after multiplication the given differential equation reduces to exact differential equation. So integrating factor is multiplying factor which converts non-exact differential equation to exact differential equation. So we have to see under which condition we can find integrating factor and how to find it. By following these 5 rules, we can find integrating factor. So rule number 1. Given differential equation which is mdx plus ndy is equal to 0 is not exact and it is homogeneous differential equation. Means m and n are homogeneous functions of x and y of the same degree. Then we call this equation as a homogeneous differential equation. Moreover, xm plus yn which is not 0. Then integrating factor is 1 by xm plus yn. Rule number 2. Given differential equation mdx plus ndy is equal to 0 is not exact, but it is in the form f1 of xy into y dx plus f2 of xy into x dy is equal to 0. And xm minus yn is not 0. Then integrating factor is 1 by xm minus yn. Then rule number 3. If given differential equation mdx plus ndy is equal to 0 is not exact, and da by m by da by y minus da by n by da by x divided by n, value of this quotient is f of x, is only function of x. Then integrating factor is e power integration of f of x dx. Rule number 4. If differential equation mdx plus ndy is equal to 0 is not exact, and da by m by da by y minus da by n by da by x divided by minus m, which is equal to g of y, then integrating factor is e power integration of g of y dy. Rule number 3 and 4, they are similar. If you observe carefully, this numerator is same over here, and when we are dividing it by n, that value of quotient is function of x. Here in rule number 4, when we are dividing it by m, we are attaching negative sign. So remember rule number 3 and 4. Then rule number 5. If given differential equation mdx plus ndy is equal to 0 is not exact, and it can be written in the form x power a1 y power b1 m1y dx plus n1x dy plus x power a2 y power b2 into m2y dx plus n2x dy is equal to 0. Here a1 a2 b1 b2 m1 m2 n1 n2 all are constant. Then in this case we can assume integrating factor as x power h y power k. And when we assume integrating factor x power h y power k, we multiply given equation by x power h y power k. Means for every term we increase x power by h, y power by k, and then our equation converts to exact. Then we use condition da by m by da by y equal to da by n by da by x. From that we get two polynomial equations. By equating like coefficients, we can get two equations in h and k, and solving them we get integrating factor. Once we get integrating factor by applying rule number 1 to 5, n1 of the rule, then we multiply given equation by integrating factor and we get exact differential equation. We can apply formula for solution. We evaluate integral, and from that we get final answer, means general solution. So with this, now we will go to solving problems based on equations which are reducible to exact differential equation. So problem number 1. Solve differential equation x square y minus 2x y square dx minus x cube minus 3x square y dy is equal to 0. We can easily observe these equations can't be written in the form called as variable separable form. So we compare this equation with exact one, and dx coefficient means m. So m is, we compare this equation with m dx plus n dy is equal to 0. So m is x square y minus 2x y square. Yes. And n is minus x cube minus of minus plus 3x square y. So da by m by da by y means it is x square minus 4xy. Yes. And da by n by da by x means minus 3x square plus 6xy. And obviously da by n by da by y is not equal to da by n by da by x. This conclusion is given differential equation is not exact. But m is homogeneous function of degree 3. N is also homogeneous function of degree 3. So m dx plus n dy is equal to 0 is a homogeneous differential equation. So we can use rule number 1, provided xm plus yn is not 0. So we'll find xm plus yn means x into x square y minus 2x y square plus y into minus x cube plus 3x square y. And if you simplify this x cube y get cancelled with plus minus sign, and minus 2xy square plus 3 square y, that get, yes, minus 2x square y square and plus 3x square y square, that gives x square y square, which is not 0. So integrating factor by using rule number 1 is 1 by xm plus yn, and that is 1 by x square plus, 1 by x square into y square. So once we get integrating factor as this, we will multiply given equation by integrating factor. So multiplying by integrating factor, x square y minus 2xy square dx divided by x square y square plus minus x cube plus 3x square y divided by x square y square dy is equal to 0. So if you simplify this, I think x square get cancelled, yes, 1 by y, from this 1x get cancelled, 2 by x with minus side dx. So x divided by y square with minus sign, plus 3 divided by x square get cancelled, 1y get cancelled, plus 3 by y dy is equal to 0. And this is exact differential equation. So its solution is given by formula m dx, integration of m dx assuming y constant, plus integration of terms in n free from x dy is equal to 0. So enter value of m is this value, and term of n free from x, so don't consider this value. So it is 1 by y minus 2 by x dx assuming y constant plus 3 by y dy is equal to 0. And 1 by y dx is x by y minus 2 log x plus 3 log y is equal to 0. So this is our final answer. This general solution of given differential equation. Now with this, we will go to next problem, which is solve differential equation x into x minus y dy by dx is equal to y into x plus y. So we can easily observe this equation is not in variable separable form. So we'll write it in the form of exact differential equation. So it is what? Y square plus xy dx, and you change sign of this term. So it is xy plus y square dx plus minus x square plus xy dy is equal to 0. And then we compare it with m dx plus n dy. So m is this term, xy plus y square, n is this minus x square plus xy. So da by m by da by y is x plus 2y, and da by n by da by x is minus 2x plus y. And obviously they are not equal, means da by n by da by y is not equal to da by n by da by x. So given differential equation is not exact. Therefore, we'll see whether it is homogeneous or not. Yes, m is homogeneous function of x and y of degree 2. N is also homogeneous function of x and y of degree 2. So given differential equation is homogeneous differential equation. Now to apply rule number 1, we'll find xm plus yn. So it is x into xy plus y square plus y into x square plus xy, so that this x square y with plus minus sign get cancelled, and x square y square, yes, xy square is double. So that is 2 times xy square, and that is not 0. So using rule number 1, integrating factor is 1 by xm plus yn is 1 by 2xy square. So multiply given differential equation by this integrating factor, we get xy plus y square divided by 2xy square dx minus x square plus xy divided by 2xy square dy is equal to 0. Simplify. So it is 1 by 2y, yes, plus 1 by 2x dx Then what about this term? Yes, x by minus 2y square plus 1 by 2y dy is equal to 0. It's exact differential equation. Its solution is given by formula. Formula is mdx, integration of mdx assuming y constant, plus integration of terms in n free from x dy is equal to 0. So 1 by 2y plus 1 by 2x dx, and this term we do not consider because it consists of x. So it is 1 by 2y dy is equal to 0. 2 is common, we can cancel it, and so it is dx means integration of dx is x. So it is x by y. Integration of 1 by x dx is log x. 1 by y dy integration is log. So it is x by y plus log x plus log y is equal to 0 as the final answer. So with this, we will go to problem number 3. Solve differential equation 1 plus xy into y dx plus 1 minus xy into x dy is equal to 0. This is not in the form of variable separable. So we compare this equation with m dx plus n dy is equal to 0. And m is what? 1 plus xy into y. And n is 1 minus xy into x. And obviously, if you find dou m by dou y, that comes to be 1 plus 2xy, and dou n by dou x is 1 minus 2xy. And they are not equal. So, given differential equation is not exact. So, to find integrating factor, we will see that given differential equation is in the standard form. That is, f1 of xy into y dx plus f2 of xy into x dy is equal to 0. Yes, so it is in the standard form. So, we find xm minus yn. So, x into xy, x into y means xy plus x square y square, then xy plus x square y square. So that plus xy minus xy get cancelled and we get 2 times x square y square, which is not 0. So using rule number 2, integrating factor is 1 by xm minus yn, which is given by 1 by 2 times x square y square. So once we get integrating factor, we multiply this equation by integrating factor and we get exact. So y plus xy square divided by 2x square y square dx plus x minus x square y divided by 2x square y square dy is equal to 0. Simplifying, we get 1 by 1y get cancelled, 2x square y, x get cancelled, y square get cancelled, 1 by 2x plus 1 by 2x dx. Here 1 by 2x square xy square minus 1 by 2y dy is equal to 0. Just simplify this periods. So which is exact differential equation. Its solution is given by mdx plus mdx assuming y constant plus term of n free from x dy is equal to 0. So we take this m as it is. So it is 1 by 2x square y plus 1 by 2x dx assuming y constant. Then this term consists of x, so we do not consider that. Minus 1 by 2y dy is equal to 0. Cancel 1 by 2 which is common throughout, and integration of 1 by x square is, we know, is minus 1 by x. So integration of this term assuming y constant as minus 1 by xy plus dx by x integration is log x, dy by y integration is log. So minus 1 by xy plus log x minus log y is equal to 0 as the final answer of this problem, which is general solution. So next problem, solve differential equation xy sin xy plus cos xy y dx plus xy sin xy minus cos y xy into x dy is equal to 0. Obviously, just by observation, we can see that this differential equation is in the standard form f1 of xy y dx plus f2 of xy x dy is equal to 0. And we can easily observe that it is not exact. So, you can easily find values of m and n. You can find y by y and y n by x, and you can easily verify that they are not equal. Means given differential equation is not exact. So, it is in the form f1 of xy into y dx plus f2 of xy into x dy is equal to 0. So, we find xm minus y, which is x square y square into sin xy plus xy cos xy minus x square y square sin xy minus of minus plus xy cos xy. So this term get cancelled with this with plus minus sign, and so we have 2 times xy cos xy, which is not 0. So xm minus yn is this value. So by using rule number 2, we have integrating factor as 1 by xm minus y, means 1 by 2 times xy cos xy. So, by multiplying given differential equation by this integrating factor, we get exact differential equation. So, xy sin xy plus cos xy into y dx divided by 2 xy cos xy plus xy sin xy minus cos xy into x dy divided by 2xy cos xy is equal to 0. So if you simplify, sin by cos means tan, xy get cancelled. So we have y remains as it is. So we have this y. Yes, y tan xy divided by 2. If you simplify first, if you simplify second term, cos xy get cancelled, y also get cancelled. So that's why it is plus 1 by 2x dx. From this term, sin by cos means tan, xy get cancelled, x remains. So x tan xy divided by 2. And cos xy get cancelled, x get cancelled. So it is 1 by 2y dy. So we get this equation, which is equal to 0. And this is exact differential equation. So, using formula for solution, integration of m dx assuming y constant plus integration of terms in n free from x dy is equal to 0. So we enter this value of m as it is, y tan xy divided by 2 plus 1 by 2x dx. Then term of n free from x. This term consists of x. So we are not considering this term. So that's why it is minus 1 by 2y dy is equal to 0. 2 is common in the denominator, we can cancel. And integration of y tan xy with respect to x, assuming y constant, is log of sec of xy plus 1 by x dx integration is log x. 1 by y integration dy is 1 by y dy integration is log 1. And we may take this value first of integration as log of sec. So, this is our final answer. Means general solution is given by this particular. So, if you simplify, we can use property of logarithm. Log a plus log b is log of ab. Log a minus log b is equal to log of a by b. So, we can have x by y sec of xy is equal to as a final answer. So, we solve problem number 5. Y times xy plus 2x square y square dx plus x times xy minus x square y square dy. Just by observation, we can see that this equation is in the standard form f1 of xy y dx plus f2 of xy x dy is equal to 0. It is not difficult to verify this equation is not exact. Just find values of m and n and find y m by y as well as y n by x. You will find it is these two partial derivatives are not equal, means given differential equation is not exact. So it is in the form f1 of xy y dx plus f2 of xy x dy is equal to 0. So we find xm minus ym, means x square y square plus 2x cube y cube minus x square y square minus of minus plus x cube y. So x cube y cube term we can add, and this term x square y square term with plus minus can get cancelled. So we have 3 times x cube y cube. So xm minus yn is 3 times x cube y cube, which is not 0. So using rule number 2, integrating factor is 1 by xm minus yn, which is equal to 1 by 3 times x cube y cube. So multiply given equation by integrating factor. So we multiply this equation by integrating factor, and we get y into xy plus 2x square y square dx divided by 3 times x cube y cube plus x into xy minus x square y square dy divided by 3 times x cube y cube is equal to 0. So if you simplify this, I think y square get cancelled, x get cancelled. So it is 1 by 3x square y plus 2 times y cube get cancelled, x square get cancelled, 2 by 3x dx. If you simplify this term, x square get cancelled means 1x remains here, 3 times x and y divided by is y square. So 1 by 3x y square minus x cube get cancelled, y get cancelled, means minus 1 by 3y dy is equal to 0, which is exact differential equation. So its solution is given by integration of m dx assuming y constant plus integration of terms in n free from x dy is equal to 0. So enter this value as it is, 1 by 3x square y plus 2 by 3x dx. This term consists of x, so we will not consider that. So it is 1 by 3y dy is equal to 0. 1 by 3 is common, we can cancel that. And we know integration of 1 by x square is minus 1 by x. So it is minus 1 by xy plus 2 log x, yes, minus log y is equal to 0 as a final answer. So general solution of given differential equation is given by this identity. So with this now, you can try more number of problems or even practice. And I am giving some of the problems as an assignment. Solve following differential equations. Problem number 1. X square y square plus xy plus 1 y dx plus x square y square minus xy plus 1 x dy is equal to 0. You solve this by your own. Verify. Integrating factor comes to be 1 by 2 x square y square. Solution is xy plus log x minus 1 by xy minus log y is equal to 0. Problem number 2. X square minus 3xy plus 2y square dx plus 3x square minus 2xy dy is equal to 0. We will find integrating factor as 1 by x cube. Solution is given by this. Log x plus 3y by x minus y square divided by x square is equal to 0. Problem number 3. X square y dx minus x cube plus y cube dy is equal to 0. Integrating factor is 1 by y to the power minus 4. Solution is log y minus 3x cube divided by 3y cube is equal to 0. Problem number 4. X square y square plus 2y dx plus 2 minus 2x square y square x dy is equal to 0. Integrating factor is 1 by 3 times x cube y cube. Solution is log x minus 1 by x square y square minus 2 log y is equal to 0. So do more practice, as it is said, practice makes man perfect, and definitely if you do more practice, you will have mastery over solving problems on equations which are reducible to exact differentials. So I wish you all the best, happy learning, and thanking you for listening this particular video.